Today we're talking about what happens with means and variances when you start combining things or start to change things around. So you need to think back to the first unit. You need to picture a histogram in your head. Okay? Back when the first unit, we talked about shifting and rescaling data, right? When we shifted data, we added a constant to every single data value. And so it moved your histogram up or down the number line, right? When we shifted data, did that change the center? Yes, because the center may have been at 10, but you move it up the number line, it's not at 10 anymore. Did it change the spread? No, right? Your histogram would have stayed the same in shape-wise, right? So same thing happens with random variables. If you're shifting, which means adding a constant or subtracting a constant, you're going to add or subtract to the mean. In this case, our mean is the expected value. So if you're adding or subtracting a constant to the mean or the expected value, in this case, you're actually going to add and subtract that constant from the expected to the expected value. But for the variance, which the variance didn't exist back in Unit 1, but we had standard deviation, and standard deviation didn't change because that was a measure of spread, right? Well, same thing here. Variance is still a measure of spread. The square root of the variance is still the standard deviation, right? So they're still measures of spread. The measure of spread don't change when you add and subtract constants. So if you look at the notes on the board, it says that. It says if you're going to add a constant to your random variable x, then you just take the expected value and add and subtract the constant. If you're going to add or subtract a constant to your random variable x, you leave the variance alone. Just like we did way back in Unit 1. Things have not changed. New notation and things, but still the same general rules. Is everyone okay with that? Remember, who missed stuff on quizzes about this adding and subtracting business? Because you kept forgetting that the spread doesn't change. So it's still the same. Redeem yourself in Unit 4. Okay? Questions so far? That is something that should come to you. We've seen it before. We're just kind of changing what we're doing. All right. We also talked about rescaling data. So when you rescale data, that means you multiplied it by a constant. You didn't add, subtract, you multiplied. So when you multiplied your histogram, think about your data. If you multiplied by a constant, did the center change? Yes. Did the spread change? Yes. When you started multiplying, then your histogram would have either got, depending on what you're multiplying by, would have either got scrunched up or way spread apart. Right? It wouldn't have the same shape anymore. Okay? So the same thing happens here. All right? But there's a little, we'll call it a little twist. All right? So if you're doing expected value, the mean, we know the center changes, you just multiply the mean by that constant. No big deal. That's fine. Expected value will not be the problem today. But generally we're talking about variances. When we had standard deviation in Unit 1, we just multiplied the standard deviation by the constant, right? Remember that? We multiplied the standard deviation by the constant. The standard deviation and the variance are not the same thing. How are the standard deviation and the variance related? The variance is the blank of the standard deviation. The variance is the square of the standard deviation, right? So you can't just multiply the variance by 3. Let's say we're multiplying by 3. I can't just do variance times 3. I can do standard deviation times 3, but I cannot do variance times 3. If variance is the square of the standard deviation, what has to happen to that 3, do you think? It also has to be squared. All right? So if you're dealing with the variance and you're multiplying by a constant, then 3 times the variance is really 3 squared times the variance. Right? That's one of those things, little twist things that you're going to forget if you don't practice over and over and think about it over and over. So on this next screen that has it on there, Okay, so it says in general when you're multiplying a random variable by a constant, you're going to multiply the random variable by the constant with the expected value. You just multiply the expected value, no big deal. For the variance, when you're multiplying the random variable by a constant, you have to square that constant. Okay. That should make sense. If the variance is the square of the standard deviation, just square the constant too. I could make up another rule if I wanted to. I'm not really making it up. I could write it down. The standard deviation of a constant times a random variable is just the constant times the standard deviation of x, right? So to get back up here, I would just square the whole thing. So just square the a and square the standard deviation. That's how I get a squared in the variance. That should make sense to you. That's algebra, right? The problem is, again, it's one of those things you're going to forget when you start putting it into practice. If you don't practice it and you don't think about it consciously, you will miss those questions on quizzes and tests. All right? Okay. So we know what's going to happen when we start adding and subtracting constants or multiplying constants. That's great and wonderful. But what happens when I start trying to put random variables together? All right? So what if, so our book's been using the insurance policy question. All of you have an insurance policy. Okay? But all of you are one random variable x. So like Miranda would be x sub 1. And Linda would be x sub 2. Like you're all separate individual policies. Right? So what if I wanted to know like the expected value of 2 of those things put together? Or the standard deviation of 2 of those things put together? So the rest of what we're doing today is talking about combining random variables. Okay? Again, expected value will not be the problem today. The expected value of the sum of 2 random variables is just the sum of the expected values. No big deal. Okay? If I want to know the expected value of 2 of these things put together, I just add this expected values. This also works for subtraction. If I wanted to subtract expected values, I can do that too. And yeah, you would. So generally you don't find them. Unless you're doing, you could, depending on the context of the question, if you just had x sub 1 minus x sub 2, that would be 0, because the expected value of the random variable is the same. But you could start combining 2 different variables. So you could have like x plus y or x minus y. They might not have the same mean. Or you might have like x plus 3y or x minus 3y. Those won't have the same mean. So when you're subtracting, you don't always get 0. Depends on what your variables are. Okay? All right. Before I go to the next slide. So far, I think you're following. This isn't a big deal. The last one is the super confusing part. It doesn't have to be super confusing. So I'm going to try to talk you through it before I show you the stuff. I put it on the screen and start looking at it. You won't listen to me. So you're going to listen to me first. The only thing left we need to talk about is what happens when we start adding or subtracting variances. Okay, we add and subtract expected values, so about variances. If you're going to add variances, no big deal. Right? So the variance for one variable and the variance for the other, putting them together, combine that variance. No problem. The problem comes when you start subtracting. If you have 2 different variables that represent 2 different things and they both have variability, right? Because not everything is just the mean. There's always some extra data around the mean, right? Think about your histogram. It's kind of spread out a little bit. Okay? If you start combining 2 things that both have variability, if you subtracted them, you'd be reducing the variability. But that doesn't make any sense. If you combine 2 things that are variable, they should get more variable, right? It's not going to get less variable because you put 2 things together. So here's the rule, and you have to remember this rule, and you're going to have to do it forever from now on. You can add variances, no problem. But if it says to subtract 2 variables and you're doing the variances, you still add them. So you are never, ever, 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 ever subtracting variances. Even if there's a minus sign, you are adding them. It's not an algebra problem. So it's going to tell you in problems we're doing today, They'll have like a little table with some information to use to practice, and it'll say like x minus 2y. Well, when you're doing the expected values, you'll be subtracting. But when you're doing the variances, you're going to be adding. Okay? Again, when you have two things that are already variable and you put them together, you're getting more variable. You can't subtract out variation and make it go away. There's going to have more variable all over the place. So you're always adding variances. Always adding variances. Okay? Keep that in mind. So here we have an example. It says you can add variances. No big deal. We'll talk about you can have to add them and subtract. The biggest thing on top of that you have to remember, when you're going to start combining variables, they have to be independent. That should make sense. But if you're going to combine two things, they need to be independent of each other, right? If they weren't independent, then it's like that gray area of like one affected the other or influenced the other. So do I really just add these two, or is something else going on? So they have to be independent. Okay? That normally is not a problem. But generally, you're assuming that they're independent, or if you're going to start putting things together. Okay. Here are the general rules. Has it all highlighted. If you're going to find the mean of the sum of two random variables, it's just the sum of the means. You just add them together. If you find the mean of the difference of two random variables, it's the difference of the means. You're just going to subtract them. We already talked about all this stuff. If the random variables are independent, the variance of their sum or difference is always the sum of the variances. Notice there's no plus minus sign in. We talked about this. I'm going to give you an example with the insurance question from our book so it's in context so you can understand why this happened. It says, wait a minute, is that third part correct? Do we always add variances? Well, the answer is yes. Think about two insurance policies. Suppose we want to know the mean and standard deviation of the difference in payouts to the two clients. Since each policy has an expected payout of $20, the expected difference is 0. That's the expected value, no problem. If we also subtract the variances, you get 0 too. But that doesn't make sense if you think about the payouts. Some of the outcomes, they're independent outcomes, but the difference could be Ian could pass away, and so his family gets paid out $10,000. But Trent, nothing happens to Trent. He gets paid nothing. Difference between is $10,000, right? 10,000 minus 0. What if the reverse happened, right? What if I was doing Ian? Well, then 0 minus $10,000 is $10,000. So the payouts have a $20,000 range. It could be from negative $10,000 all the way up to $10,000, right? So the variance is not 0, right? You've now made it larger. There's this bigger variability. So you have to add the variances, all right? The variability in differences increases as much as the variability in sums. So you're still increasing even when it says minus. Does that help a little bit? Okay. Something you have to remember. Now, when you're combining variables, notice that none of these things have standard deviation in them. Right? When you're doing just multiplying by a constant or adding a constant, you can do that with standard deviation. It's not a problem. We did that before in Unit 1. But if you're starting to combine variables, you cannot add standard deviations. It doesn't work that way. So you're going to have to add the variances first and then take the square root. All right? It does not work that you can just add the standard deviations. If you think about rules of radicals, that will make sense. Okay? Yes? Maybe? So I'm going to do some examples. And then towards the end, I'm going to let you practice them to make sure you know what you're talking about. Okay? So the ones today are going to look like algebra problems, but they're really not algebra problems. Think about the random variables. X and Y are random variables. They are not like algebra variables. All right? All right, so here's the first one. Because given independent random variables, so we know they're independent, we don't have to worry about it. With means and standard deviations as shown, find the mean and standard deviation of, and it gives you 5 things you have to do. Some of these are easier than others, no big deal. Okay? So, on A, you're just multiplying by a constant. I'm going to find the expected value of 3x and the standard deviation of 3x. If you're just rescaling or multiplying by a constant, what do? You just multiply stuff, right? So the mean of x is 10. So the mean of 3x is 30 times 10, or 30. That is not complicated. Same thing with standard deviations. If you're multiplying by a constant in unit 1, could you multiply the standard deviation by a constant? Yes, you could. So you're doing the same thing here. Standard deviation is going to be 3 times 2, which is 6. Now, if you're using the rules that you wrote down, there is no rule written for standard deviation. Okay? So let's say we're using the rule from the book. The rule from the book says the variance of a times x equals a squared times the variance of x. Okay? So what is our a here? What's our constant we're using? 3 is our constant, right? It's 3 times x. That would be 3x right there. So we have 3 squared times the variance of x. How do I find the variance of x from the standard deviation? How do I find the variance? You square it, so it's 4, right? So 9 times 4 is 36. That's the variance. And if I want to find the standard deviation, I would just take the square root, right? Which is also 6. Yes? Not for this one. But since there isn't actually technically a formula for that in your book, if you're using the ones from the book, it would be that. Questions about that? We're going to have to find the mean and standard deviation for yes, A, B, C, D, and E. No, it's asking for the mean and standard deviation, but when we start combining, you can't combine standard deviations. We're going to have to know the variance anyway. So what's I just put a box around is the answer to A. That one should not be a problem. Questions about A? All right, question on B. Same thing, mean and standard deviation, but it's y plus 6. So I have to think consciously about what happens when you add a constant. So what happens to the mean when you add the constant? Yeah, it shifts, so you just add it. So you have, the mean is 20, and you add 6, so you get 26. No big deal. But for the standard deviation, when you add a constant, the spread stays the same. So the standard deviation does not change. So it's still 5. It does not turn into 6. If you don't add the 6, you don't get 11. 5. Nothing else. So far, so good on A and B. Let's get an example of multiplying by a constant, an example of adding a constant. Can I erase everything I have so far? Because I'm going to need some space. All right. Yes. On C, D, and E, we are combining 2 variables. I've been saying you can't combine standard deviations. It doesn't work that way. So we're going to have to use variances. So you may as well find them out anyway. We already had the variance of x was 4. So what's the variance of y? We're going to need to use those. Okay? On all of these questions, the expected value should not be the hard part. So on C, we're adding x and y. So how do I find the expected value, or the mean? Add them. So 10 plus 20 is 30. Ta-da! But when we find a standard deviation, you have to do the variance first. Have to. No other option. If you do the standard deviation, you'll get it wrong. So it says we can add variances, right? So we're going to add variances. So we have 4 plus 25, which is 29. That's sigma squared. The question, however, asks for standard deviation, so I have to take the square root. Questions about that? That wasn't so bad. But I'm just trying to make sure you realize that you can't just do standard deviations as you want to. Questions? Does that make sense? Yep. No. All half the same answer. On D, we're doing x minus y. So for the mean, what do? Subtract. So 10 minus 20, because order matters still, it's still subtraction. You get negative 10. For the standard deviation, though, we would go back to variances, right? And we would add them. We already did that. We did it in part C. So the standard deviation for D is the same as the standard deviation for C, because we're still adding variances. Okay? Yeah? Okay. On E, I have two different random variables. They have subscripts 1 and 2 because if they didn't, knowing you all, because you're algebra people, if they weren't there, you would be tempted to do 2x. X plus x is 2x. But that's not how this works. All right, that's why we have subscripts, to make sure you know it's two separate random variables representing the same whatever. It's two separate insurance policies, whatever. Okay? So you're going to use these properties of combining them. You can't just multiply by a constant of 2. That doesn't work. So on E, for the mean, what are we going to get? Plus 10, which is 20. Yeah? Okay. And then for this standard deviation, we have to find the variance first. I remember I can't combine the standard deviation. So for the variance, I'm going to add the variances. So 4 plus 4, which is 8. And then I take the square root to get the standard deviation, and that's 2.8. Does that make sense? Yes, no, possibly, could be. So biggest things you have to remember here so far is that you add variances. You never add standard deviations. You add the variances. And you take the square root at the end. Right? We good? All right. I'm going to do one more example that's like the next step. And then I'm going to let you work on some so I can see if you know what you're doing. Okay? Can I clear all this off? All right. Same type of question, just the pieces are a little more complicated. Still independent random variables. We want to find the mean and standard deviation. But if you notice, these are just a little more complicated. I'm going to do D. It says 3x minus y. I need to know the stuff for 3x before I start combining stuff with y. So that's what I'm going to do. Okay? So I'm going to worry about 3x by itself first. Just worry about 3x. So I need to find the mean of 3x, and I need to find, since we're going to be combining it with another random variable, just the variance. I don't have to worry about the standard deviation because I'm going to be combining it, and I can't combine standard deviation. So for the mean, what am I going to get? 360. Right, 360. 3 times 120. Everyone good with that? Again, that should not be the hard part. For the variance, now this is where it's going to be tricky because you aren't going to think it through because we didn't do one like this last time. If you're doing the variance, remember variance of 3 times x is 3 squared times the variance of x. Okay? You're going to forget that part. That's what the formula says. If you're doing a constant times the variance, you have to square that constant. Remember? All right, so 3 squared is 9. And you have the variance would be 144. So you have 9 times 144. I don't remember what that is. Do I believe you? I don't know. Okay. You never know. I don't need to find the standard deviation because I'm combining it with something else. So the standard deviation would be, if you found it, you just wouldn't use it again. Okay? But is everyone good with me finding 3x? This is the part that you're going to mess up if you don't think it through. Everyone good so far? To finish this question, I actually have to do the 3x minus y. So, for the mean of 3x was 360, minus the mean of y is 300, so it's just 60. You should get every single expected value question right. Yes. This is the variance, and since we're going to be combining it in this next part, you can find the standard deviation, but it won't help you. Because when you're combining them, you have to add variances. You can't add standard deviation. All right, so for this standard deviation part, I need to find the variance first. Okay? It says minus, but that doesn't mean anything because we're still going to add. So I'm going to take the variance of 3x, which is 1,296, and I'm going to add the variance of y, which is what, 256? So I'm going to add those together. What's that? That sounds good. And then now I want to find the standard deviation. So now I take the square root. Do we see how it was helpful to find 3x first? Yeah. And it's important that you remember that you square the constant before you multiply it by the variance. Again, the standard deviation is the square root of the variance. So the variance is the square of the standard deviation. So if you have a constant, you just square it too. All right, I want you to do the other 4 of this one. A, B, C, and E. And then we'll check your answers. Right now. Okay. You should have A and B. On A, the mean is 240 and the standard deviation is 12.8. You multiply both of those by 0.8. On B, you have 2x minus 100. So on the mean, you do 2 times 120 and then subtract 100 to get 140. For the standard deviation, you do 2 times 12, but then you don't subtract 100 because you don't add and subtract the standard deviation just like in Unit 1. So you already forgot that when I told you today. Again, imagine that histogram in your head. If you shift it, the shape doesn't change, the spread doesn't change. A constant, right? If it says plus 7 or plus 8 or minus 120, don't subtract constants or add constants. You could still get 24. You have to do 2 times, well, 2 squared, so 4, times the variance of x, so 4 times 144. Take the square root of that. There you go. It all works out. Questions on A or B? All right, on C then, I have x plus 2y. So I'm going to find 2y first, and then I'm going to go back and add x and all that stuff. So for 2y, the mean is 600. Again, you should have that part. And then this variance is 2, it's the constant squared, times the variance of y. So 4 times 256 is 1,024. That's the variance for the 2y part.
So how come we have to do the variance first? We didn't have to do the
You have to use the variance when you're combining two random variables. So on A and B, there's only one variable. So when I do x plus 2y, the means, again, that should be the easy part. You do 120 plus 600, you get 720. Right? So then for the variance, you add the variance of x, which is 144, plus the variance of 2y, which is 1024. And you add them, you get 1168, and then you take the square root, you get 34.2. This is the part you need to remember right here. Questions about C? Things we're still confused about? What step are you confused about? Okay. I'm going to be combining two variables, x and 2y. So I know I'm going to have to combine variances because you can't add standard deviations together. So I need to find the variance of 2y. So that's what sigma squared stands for, is variance. So I have the variance of y, which is 256, times the constant squared. That's what that formula says. And then when I go back to combine them, x plus 2y, I already have the variance. I can just add them together and take the square root. Questions about C? And then E, you're adding y1 plus y2. So the mean is 600, 300 plus 300. You have to add variances. So 256 plus 256, you get 512. Square root of 512 is 22.6. Well, the standard deviation's in the table, so if you're doing variances, you have to square it.
I feel like if I do it,
You'll have more to do on the homework tonight.
What?
You have more to do on the homework tonight, so no fear.
I'll do it.